Hello and welcome to Sir Optics Academy. In today's video, we'll be looking at how we can use the prefixes iso, sec, tert, and neo in common names of organic compounds. Now, when it comes to how to use these prefixes in common names of organic compounds, many find it difficult on how to identify which is iso, which is sec, which is tert, and which is neo. Now, in this video, we are going to clarify on how you can correctly use these four prefixes in naming organic compounds. Now, we are going to start with the first word, which is iso, prefix iso. Now, the prefix iso is used in organic compounds that have a methyl group attached on the second to the last carbon atom that is connecting to the parent chain. Now, when you have a methyl group connecting to the second to the last carbon atom that is connecting to the parent chain of a particular organic compound, that is when you have the prefix iso being used. Now, this connection makes it possible to have this particular shape. The connection makes it look like that of a Y shape. That is to say that you have a carbon atom here that is bonding to CH3 and is bonding to another CH3. So this is how the structure of an iso look like. So now this carbon is bonding to CH3 and CH3. So now let's look at some examples on how we can name organic compounds using the prefix iso. On number one, we have this CH3 that is connecting to a carbon. Now, this is what I'm trying to talk about. When you have a methyl group attached on the second to the last carbon atom that is connecting to the parent chain of an organic compound, that is when you have an iso. That is when an iso is being used. Now, in this case, this is an isopropyl. Why? Because you have three number of carbon atoms that is connecting to the parent chain. Now, this parent chain can be any organic compound that is taking priority over this. Now, for this, we are going to call it an isopropyl. Isopropyl. Now, let's look at another example. Let's say we have this. Let's call this example 2. Now, let's say we have this to be the longest continuous carbon chain. To be the longest continuous carbon chain, and then we have a methyl attached on the second to the last carbon. What are you going to call it? Now, this is no longer going to be an isopropyl, but an isobutyl, because you have 1, 2, 3, and 4 number of carbon atoms that is bonding to the parent chain of an organic compound. So the name of this becomes iso. Why? Because of the CH3 bonded to the second to the last carbon. But now, instead of isobutpropyl, we'll call it isobutyl because of 4 number of carbon atoms. Now, let's look at another example. Let's call it example 3. We have a CH3 bonding to CH, which is bonding to CH3 and is bonding to a chlorine atom. Now, let's say this chlorine atom is the parent chain in the parent organic compound in this particular structure. So what is the trivial name? What is the common name of this particular structure? The common name of this particular structure becomes iso propyl chloride. So this is how you name organic compounds with the prefix iso. A methyl group bonded to the second to the last carbon atom of the parent chain. Now, if you try to observe all of these compounds, you will see that all of them give you the Y shape. The Y shape which indicates. So going by the IUPAC name, what are you going to give the IUPAC name of this particular structure? Now, the IUPAC name, you first of all identify the longest continuous carbon chain, which in this case is 1, 2, 3. Now, on carbon 2, you have a chlorine atom attached to this. So, the IUPAC name of this particular compound becomes 2-chloropropane. So this is the IUPAC name of this particular compound, but then this is the common name, isopropyl chloride. So this is how you are able to identify an iso in organic compound. Let's say we have another example. Let's call this example 4. Now we have it this way. Let's say now we have an OH attached to it instead. Now we can see the iso being indicated. So the common name of this is iso, but now it's not going to be isopropyl because of the 4 carbon atoms. So instead the name is isobutyl alcohol. Isobutyl alcohol. So that is how you are able to identify the parent name, the common name of iso in organic compounds. So if you are going by the IUPAC name, you count the longest continuous carbon chain, which is 1, 2, 3. Then on carbon 2, you have a CH3, which is a substituent attached to it. So on carbon 1, you have your OH, which is taking priority in the organic compound. So the IUPAC name of this becomes 2-methyl propan 1 ol. So this is the IUPAC name of this particular compound. But then the common name is isobutyl alcohol. So that is how you are able to name organic compounds using the prefix iso. Let's look at one more example on how to use the prefix iso in organic compounds before we move to the prefix sec. So now let's call this example 5. Now in example 5 we have this. Now what are you going to call the common name of this particular compound? Now you can identify the prefix iso in this particular compound. So the name becomes isobutane. Isobutane. No longer isobutyl because the whole structure is not bonding to any other parent chain, but instead it is as a whole structure. So the name becomes isobutane. Isobutane. So the IUPAC name of this is 2-methyl propane. 2-methyl propane. So that is how you are able to identify and name the organic compounds using the prefix iso. Isobutyl, isopentyl, isopropyl, anyone that you use. Now, for you being able to identify that the CH3 is bonding to the second to the last carbon, which is giving you the Y shape, is a key logic on how you can name organic compounds using the prefix iso. Now let's look at how to name organic compounds using the prefix sec. Now, the prefix sec is used in organic compounds that have an alkyl group other than a CH3, other than a methyl, that have any other alkyl group other than a methyl attached to the second to the last carbon atom. Now, you can notice that a compound can be iso and also be secondary. Now, look at this particular carbon. This particular carbon is an iso, also a secondary carbon, because it is bonding to two other carbon atoms. So, a sec can also be a secondary carbon atom, but it can never be an iso. Why? Because if the other alkyl group that is bonding to the second to the last carbon atom is a methyl, then it is no longer a sec but an iso. Now, let's look at some examples. Let's call this example 1. And then on the second to the last carbon, let's say we have an bonding to it, an ethyl bonding to it. So now you can see that this is the second to the last carbon atom that is connecting to the parent chain of the organic compound. But then on the second to the last carbon atom, the other alkyl group that is bonding to it is not a methyl. So when the carbon atom that is bonding to the parent chain has an alkyl group bonding on it that is not a methyl, that is when you have the prefix sec. That is when you have the prefix sec being used in that organic compound. Now, in this case, we are going to call the name of this compound to be sec because of 1, 2, 3, 4 number of carbon atoms. It is butyl because it is connecting to a parent chain. That is why it is a sec butyl, not a sec butyl. Now, let's look at a second example. Now, let's say the alkyl group that is bonding to the second to the last carbon atom is a propyl in this case. Now, we are going to call this sec 1, 2, 3, 4, 5 number of carbon atoms. So the name becomes sec pentyl, sec pentyl, sec pentyl. Example 3. Now, let's say we have CH3, CH, CH2, CH3 that is bonding to a chlorine atom. So the name of this particular structure becomes sec butyl, sec butyl chloride, sec butyl chloride, sec butyl chloride. So that is how to name organic compounds using the prefix sec. Let's say we have another example. Let's say we have another example, example 4. Now, in example 4, we have the structure given this way. Now, let's say this is the structure we have, and then this structure is bonding to a parent functional group, the alcohol functional group. So how are we going to name this particular structure using the common name and the prefix sec? Now, in this case, we have this ethyl, this propyl connecting to the second to the last carbon atom. So the name of this particular structure becomes sec 1, 2, 3, 4, 5, 6 sec hexyl alcohol, sec-hexyl alcohol. So this is how you're able to name organic compounds using the prefix sec. Let's look at one more example. Let's call it example 5. So we have it given this way. Now, how are you going to name this particular structure? The name of this structure becomes, the common name becomes sec-pentene. Sec-pentene, because it is not connecting to any other functional group apart from the whole structure being as a whole. So now let's look at the IUPAC name of these two structures. Now you can feel free to try the IUPAC name of the first three structures that we tried. So now the IUPAC name of this particular structure, first of all, you identify your functional group, which in this case is OH. So counting by this, the longest continuous carbon chain in this case is 1, 2, 3. So you have, this was supposed to be CH2. Yeah. So this is 1, 2, 3, 4, 5. This is the longest continuous carbon chain. So on carbon 3, we have a methyl. So this is 3 methyl. 5 number of carbon atoms spent. 1 O. So this is the IUPAC name of this particular structure. So for this, to count the longest continuous carbon chain, which in this case is 1, 2, 3, 4. On carbon 2, you have a methyl. So this is 2 methyl, 4 carbon atoms, butyl. 2 methyl butyl. So that is how you are able to identify organic compounds. That is how you're able to name organic compounds using the prefix sec. Now let's go to number 3 on how to name organic compounds using the prefix Tert. Now, how to name organic compounds using the prefix Tert. Now, organic compounds that are named using this prefix are organic compounds that have 2 methyl group connecting on the second to the last carbon atom that is bonding to the parent chain. Now, let's say we have an organic compound CH3. Now, in this particular structure, you have 2 methyl groups that are connecting on this particular carbon, which is connecting to the last carbon atom. Now, let's say this particular carbon is connecting on the second to the last carbon atom that is bonding to the parent chain of this particular structure. So when you have 2 methyl group that is attached on a carbon atom which is connecting to the parent chain, now this carbon atom will be the second to the last carbon atom. So let's say for a Tert, you have this particular shape. Unlike alkanes, unlike iso, that we have the Y shape. This is how you are able to identify organic compounds and name organic compounds using the prefix Tert. So now, here you have a CH3. Here you have a CH3. And here you have a CH3. So this is how you are able to identify organic compounds or then identify and name organic compounds using the prefix Tert. Now, if you are to name this, the name becomes Tert 1, 2, 3, 4. Now, one thing about using the prefix Tert is that you can't have anything other than Tert butyl. It is always Tert butyl. You cannot have Tert pentyl, because when you have Tert pentyl, then that is automatically wrong, because first of all, you are no longer dealing with the Tert, but you're dealing with the prefix nil. Now, when we get to the prefix nil, I will explain why I said so. So, this is how you are able to identify and name organic compounds using the prefix Tert. Let's say we have another example. Now, let's say this is bonding to a chlorine atom. It can be a bromine. It can be any other functional group. So, the name of this becomes Tert butyl chloride. Tert butyl chloride. That is how you identify it. So, on number 3 now, let's say we have another organic compound. We have this. And then it is bonding to OH. What are you going to call this? Feel free to pause the video and try the answer. So here we have Tert butyl alcohol. What are you going to call these two structures as the IUPAC name? Apart from you giving them the common names, what are the IUPAC names of these two structures? Now here, the IUPAC name of this becomes, first of all, you choose the longest continuous carbon chain, which in this case is 1, 2, 3, or 1, 2, 3. So on carbon 2, you have a chlorine atom. So that is going to be 2-chloro. Also, on carbon 2, you have a methyl. So it's going to be 2-methyl. Then the longest continuous carbon chain is 3. So it is 2-chloro, 2-methyl propane. 2-chloro, 2-methyl propane. So for this now, this is the functional group. So going by the longest continuous carbon chain, in this case, is 1, 2, or you can say 1, 2, or you can say 1, 2, but not more than 2, because this is the longest continuous carbon chain. So now let's go with this and this. So on carbon 1, you have 2-methyl, and you also have your OH. So this is just a 2-carbon atom, so there is no need showing the position of your OH. So because if it's here or it's here, it's still on carbon 1. So on carbon 1, you have 2-methyl. So that's going to be 1, 1 dimethyl ethanol. 1, 1 dimethyl ethanol. So this is how you are able to name organic compounds using the prefix Tert. So lastly, let's look at how to name organic compounds using the prefix new. How to name organic compounds using the prefix new. Now, the prefix new is used in organic compounds that have 2 methyl groups that are attached on the second to the last carbon atom, which is connecting to the parent chain with a CH2 linkage. Now, let's look at an example. We have CH3, and then this is the second to the last carbon atom. We have 2 methyl group connecting to it, and then a CH2 linkage. So when you have two methyl group attached on the second to the last carbon atom with a CH2 linkage, we'll have our prefix nil. So now look at why I said the prefix tat cannot be anything other than tat butyl, because when you have this to be tat pentyl, then that is automatically wrong, because there's nothing like tat butyl, tat pentyl. Only what you have is neopentyl. So now tat butyl, tat can only be tat butyl, but neo can be neopentyl and above. So now the name of this particular structure using the common name becomes neopentyl. Neopentyl because of 5 carbon atoms. So let's look at another example. Let's say we have CH3 bonding to a carbon connecting to CH3 that is connecting to this CH2, and then let's say we have a chlorine atom attached to it. Now, what are you going to call this particular structure? This particular structure, the common name becomes neopentyl chloride. Neopentyl chloride. So this is how you are able to identify and name organic compounds using the prefix neo. Let's look at two more examples on how we can identify and name organic compounds using the prefix neo. Now let's say we have this. Now, what are you going to call this particular structure using the common name, using the prefix neo? Now, for this particular compound, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 number of carbon atoms. Now, the last carbon atom is connecting to a parent chain. So, for that case, the name becomes neo because of the CH2 linkage and 2 methyl group connecting on the second to the last carbon atom, neohexyl. Now, let's say on this last carbon atom, we have an alcohol group attached on it. An alcohol group attached on it. So what are we going to call this? The name of this particular structure becomes neohexyl alcohol. So now it cannot just be a chlorine or an alcohol, it can be any other functional group as far as naming it using the prefix iso, sec, and tet and neo is possible for that particular structure. So now look at this. What are you going to call this? What is the IUPAC name of this particular structure? Now, first of all, take the longest continuous carbon chain, which in this case is 1 to 3 number of carbon atoms. Now, on carbon 2, we have 2 methyl groups, and on carbon 1, we have a chlorine atom. So the name becomes 1-chloro. Then on carbon 2, we have 2 methyl, so it's going to be 2,2-dimethyl. Now the longest continuous carbon chain is 3 carbon atoms, so it's propane. So that is the IUPAC name of this particular structure. Meanwhile, this is the common name. So for this now, this is our functional group taking priority. So we are going to start counting from this particular carbon. So we have 1, 2, 3, and 4 longest continuous carbon chain. So on carbon 3, we have 2 methyl. So it's going to be 3,3 dimethyl. The longest continuous carbon chain is 1, 2, 3, 4 number of carbon atoms, which is butane, 1 all. The all indicating the alcohol functional group. So this is how you are able to name organic compounds using the prefix iso, sac, tat, and neo. Now, before we end this class, I would like to give us some practice questions so that we can try and identify which of them is iso, which of them is sac, which of them is tat, and which of them is neo. Now, here are the practice questions. So feel free to try this practice question and see how you can identify which of them is iso, which of them is sec, which of them is tat, and which of them is named using the prefixes new. So this is all for this video. Now, if you find this video helpful, please consider liking and commenting on this video. So I'll be happy if you do these practice questions and drop the answers in the comment section. So thank you so much for watching.